This slide introduces the ASCE Geotechnical Group luncheon presentation regarding major geotechnical failures resulting from Tropical Storm Faye in 2008. The presentation was delivered by Dr. Devo Siriram of Devo Engineering, focusing on areas such as Debari, Orange City, and Rock Springs in Central Florida, regions heavily impacted by flooding. Visuals depict submerged roadways and the operation of a pump to remove floodwaters, highlighting the storm's impact on local infrastructure. Slide 2 acknowledges the various sources of information used in the investigation. Helicopter photos of the Debari failures were provided courtesy of professional engineering consultants. Rainfall data and maps were compiled from NOAA, Weather Underground, and Devo engineering files. Additional information was obtained from the local news, including reporting on the flooding of Fish Memorial Hospital. The main menu outlines the key areas of investigation following Tropical Storm Faye. These include rainfall analysis, structure flooding, infrastructure impacts, and geotechnical failures. Also included are lessons learned and future direction. We now turn to rainfall data collected during Tropical Storm Faye. This slide, the first of our data presentation, highlights the 5-day rainfall totals at various stations throughout Florida. This is the rainfall that contributed to the damage we will later examine. Here are bullet points summarizing Tropical Storm Faye, which impacted Florida from August 18th to 24th, 2008. Tragically, 14 people died, and thousands of homes and commercial properties sustained damage from 60-mile-per-hour winds and floodwaters up to 5 feet deep. The tropical storm made 4 landfalls in Florida, including Key West and Cape Romano. Here we see the rainfall totals for Tropical Storm Faye, according to NOAA data. The heaviest rainfall, exceeding 25 inches, was concentrated in a band stretching from Fort Myers to Melbourne. The maximum recorded rainfall was 27.65 inches, observed near Melbourne. Tropical Storm Faye's behavior was as unpredictable as its rainfall. After crossing central Florida, Faye unexpectedly strengthened to 65 miles per hour over land, developing an I feature. The westward deflection resulted in another landfall at Flagler Beach in the afternoon of August 21st. Faye made its 4th and final landfall on the morning of August 23rd near Carabel in the Florida Panhandle. On August 19, 2008, Tropical Storm Faye was positioned over Florida. The storm brought 5 days of torrential rainfall that exceeded record levels at various stations throughout the state. This is a look at the storm from space. Tropical Storm Faye was not unprecedented. Since 1950, only 2 other storms have followed a similar path through the state: Tropical Storm Florence in 1960 and Hurricane Gordon in 1994. The color-coded rainfall map produced by NOAA showed rainfall reaching up to 25 inches in some areas of Florida. On August 21, 2008, President George W. Bush declared the entire state of Florida a federal disaster area. This slide displays the track of Hurricane Gordon in 1994, a tropical cyclone that impacted the state of Florida. The graphic illustrates the path Gordon took as it approached from the south, initially impacting the Bahamas, then making landfall near Florida's southern tip before traversing the state and eventually exiting into the Atlantic Ocean off the coast of Georgia. The map also shows the storm's progression relative to key geographical locations, including the Bahamas, Florida, Georgia, and Alabama. This slide illustrates the path of Hurricane Florence in 1960. The storm made landfall in the Florida Panhandle, crossed the state, then exited into the Atlantic Ocean, moving across Cuba and the Bahamas. Its projected path is superimposed on a map showing the states of Arkansas, Louisiana, Mississippi, Alabama, Georgia, and South Carolina. The NOAA published rainfall map reveals that Orange City, in Volusia County, received approximately 20 inches of rain during the multi-day storm. Notably, the area within the Orange City-DeBerry-Deltona Triangle experienced the most substantial rainfall, ranging from 20 to 25 inches. Measurements from rain gauges near Debari and Orange City confirmed that the storm generally brought between 21 and 22 inches of rainfall between August 18th and 23rd of 2008, with a significant portion occurring on Thursday, August 21st. This rain gauge map highlights the widespread rainfall distribution throughout the region. The gauge near Rock Springs recorded 21.81 inches, while the gauge along the St. Johns River near the top of the map recorded just 7.59 inches. Other notable amounts were 21.47 near Saxon Boulevard and 23.46 on the eastern side of Lake Monroe. While the rainfall from Tropical Storm Faye was significant, it did not surpass existing records. In September 1950, Hurricane Easy delivered 38.70 inches of rain in a 24-hour period in Yankeetown, Florida. However, that record was ultimately eclipsed by Tropical Storm Claudette, which inundated Alvin, Texas, with 42 inches of rain in a 24-hour period in 1978. Hurricane Easy in 1950 brought widespread rainfall to Florida, with a maximum recorded amount of 38.70 inches falling in Yankeetown. A wide area of the state, including the cities of Tampa and Ocala, recorded rainfall in excess of 10 inches. The hurricane's track is indicated by the yellow line moving inland along Florida's west coast. This slide illustrates the rainfall totals in Florida during Hurricane Georges in 1998. As seen on the map, the maximum rainfall recorded was over 38 inches near Munson, Florida. The track of the hurricane is also shown, moving inland along the panhandle of Florida. Slide 2 presents a comparison of the actual rainfall amounts to the theoretical 100-year, 10-day storm event. This comparison forms a crucial element in assessing the storm's severity. Such comparisons are vital to understanding the extent of its impact on Florida's infrastructure. This graph displays the rainfall amounts recorded at weather stations near DeBary, Florida during Tropical Storm Faye in August of 2008. Notably, the rainfall on August 22-23 exceeded the FDOT 100-year, 10-day design storm event projection of 19 inches. Several days also surpassed the 100-year, 4-day design storm projection of 15 inches. We now turn to the subject of residential structure flooding, with specific attention to issues encountered in Florida following Tropical Storm Faye. Our assessment will encompass the causes and consequences of such flooding. Further investigation into the mechanisms of water damage will follow. Here we see an overview of residential structure flooding locations following Tropical Storm Faye. Noteworthy areas depicted include Quail Lake, Lower Lake and Lakeside, Lake Susan, Kings Lake, Pine Valley Court, James Pond, and Lake Charles. These locations appear to be clustered around the Interstate 4 corridor and the Veterans Memorial Parkway. This slide illustrates the location of the DGCC Lower Lake and Lakeside community, where 40 structures experienced flooding during Tropical Storm Faye. The aerial photograph highlights the project location and provides a visual representation of the extent of the inundation in relation to nearby residential areas and roadways such as Highway 17 and 92. Notably, the impact was concentrated in specific areas, emphasizing the localized nature of the flooding event. This image depicts the devastating flooding in the DGCC Lower Lake and Lakeside community, where 40 structures were inundated following Tropical Storm Faye. The aerial view reveals water levels reaching the rooftops of homes, underscoring the severity of the residential flooding during the storm. This serves as a stark visual representation of the challenges faced by homeowners and the extent of the damage caused. This image depicts the DGCC Lower Lake and Lakeside community inundated with floodwaters, a result of Tropical Storm Faye. Noticeably, approximately 40 residential structures are significantly flooded, with water levels reaching the base of the homes. The aerial perspective reveals the extent of the flooding, turning the residential area into a virtual extension of the lake. This slide illustrates the extent of residential structure flooding in the DGCC Lower Lake and Lakeside area, where at least 40 structures were affected. An aerial view reveals numerous homes submerged in floodwaters, with water lines reaching significant heights. The image underscores the widespread impact of the flooding event on this community. Here we see the extent of the flooding in the DGCC Lower Lake and Lakeside community. Notice the extensive submersion of residences. The slide title indicates that 40 structures were flooded. This residential structure flooding highlights the severity of the storm's impact on this community. Here we see an aerial view of the Kings Lake community, where 16 structures were flooded. The project location marker indicates a concentrated area of impact. Note the proximity of residential areas to both open water and the golf course, which may have influenced the storm water flow. This aerial view shows the Kings Lake community and the widespread flooding caused by Tropical Storm Faye. 16 structures were flooded in this residential area, demonstrating the extensive damage caused by the storm. The ASCA Geotechnical Group luncheon presentation details the engineering analysis of this event. This aerial view shows flooding in the Kings Lake community, where 16 structures were impacted. The waters have risen to the point of inundating homes and roadways. The extent of damage will require careful assessment. Here we see an aerial view of Kings Lake, with at least 16 structures impacted by floodwaters. The extent of the inundation highlights the widespread damage to residential properties in the area. This photograph serves as stark evidence of the devastating impact of Tropical Storm Faye. This slide focuses on Lake Susan, where 12 structures were flooded during the storm. Aerial imagery and close-up photographs document the extent of the inundation, with several residential properties and commercial buildings submerged. The project location, situated near State Road 17, highlights a critical area impacted by the flooding. This aerial view shows Lake Susan, with an estimated 12 structures experiencing flooding during Tropical Storm Faye. The photograph captures the extent of inundation on properties bordering the lake, highlighting the storm's impact on residential areas. The proximity of residential development to the lake contributes to the flood risk in this area. The aerial photograph depicts Lake Susan, where 12 structures were flooded during the tropical storm. The elevated water levels surround homes, extending beyond normal shorelines and into residential areas. The extent of the flooding is clearly visible in the residential area on the left side of the lake. This image depicts the inundation of residential structures in Lake Susan, Florida, following Tropical Storm Faye. Aerial reconnaissance confirms that at least 12 structures have experienced significant flooding. Note the extent of the floodwaters, submerging properties, and disrupting infrastructure, illustrating the storm's devastating impact. This image depicts the extensive flooding of residential structures surrounding Lake Susan. Note that 12 buildings were severely impacted by floodwaters during Tropical Storm Faye. The widespread inundation highlights the devastating impact of heavy rainfall and inadequate drainage systems in vulnerable communities. This slide presents an aerial view of James Pond and surrounding residential areas, highlighting the scope of flooding that impacted 9 structures. Project location is denoted by a yellow pin, indicating the focal point of the damage assessment. Inset images further showcase the inundation of homes, illustrating the severity of the residential structure flooding during Tropical Storm Faye. This aerial photograph depicts the extent of flooding at James Pond, where the water level has risen to submerge multiple residential structures. Note the widespread inundation of properties, indicating a significant breach of the pond's capacity to contain stormwater runoff during Tropical Storm Faye. 9 structures were flooded in this area. This image documents the extensive flooding in the James Pond community, with at least 9 structures submerged during the storm. The aerial view reveals the extent of the inundation, with floodwaters reaching residential properties and surrounding infrastructure. Such widespread flooding underscores the severity of the storm and its impact on local communities. James Pond experienced extensive flooding, with 9 structures inundated by the storm's relentless deluge. This aerial view starkly illustrates the scale of the disaster, as homes are submerged, highlighting the vulnerability of residential areas to extreme weather events. This is photo 3 of 3. This slide illustrates the flooding damage sustained at Pine Valley Court, where 6 structures were impacted. Inset imagery shows severe residential flooding in the area. The project location indicator on the map places the damage within a community adjacent to Highway 17 and near Glen Club Drive. This aerial view captures the devastating impact of Tropical Storm Faye on Pine Valley Court, where 6 structures were flooded. The image shows water inundating homes, extending well beyond the foundations and transforming the landscape into a waterlogged scene. This residential area experienced extensive flooding during the storm. This image depicts the extensive flooding of Pine Valley Court, where 6 structures were inundated by the storm's deluge. The aerial view reveals the depth of the floodwaters, which submerged roads and reached the roofs of some homes, underscoring the severity of the disaster. This scene serves as a stark reminder of the devastating impact on residential areas. Slide 42 details the flooding situation around Quail Lake, where 2 structures were impacted. The overview shows the relative location of the neighborhood in relation to Quail Lake, with closer views highlighting properties experiencing significant flood inundation. The project location is generally identified near DeBari Plantation Boulevard. The photograph shows a residence in Quail Lake, one of 2 structures flooded during Tropical Storm Faye. The water level is high enough to reach the garage door of the house, which is identified by the number 520. The flooded yard and driveway indicate significant inundation due to the storm event. This photograph shows one of the residential structures in Quail Lake affected by the flooding. Water inundates the driveway, nearly reaching the garage door and reflecting the house. As we can see, standing water extends all the way up to the front door. This slide depicts Quail Lake, where 2 structures were flooded during Tropical Storm Faye. An aerial view reveals the lake and surrounding residential development. The extent of the inundation is evident, showcasing the impact of the storm on local infrastructure. This image documents the inundation of properties along Quail Lake, with floodwaters rising significantly. Note the submerged pool cage and shrubbery, which attest to the severity of the flooding. The adjacent lake is visibly swollen beyond its typical banks. Here we see an aerial view of Lake Charles, where 1 structure was flooded. The project location appears to be in close proximity to a baseball field and Deltona Boulevard. This image was captured August 29, 2008. Slide 48 depicts an aerial view of Lake Charles in Florida, showing the extent of residential structure flooding caused by Tropical Storm Faye. Note that at least 1 structure is severely affected by the floodwaters. The photo documents the storm's devastating impact on residential areas. This image documents the residential structure flooding in Lake Charles. Notice that at least 1 structure has been completely inundated by floodwaters as a result of Tropical Storm Faye. The widespread impact of the storm on residential areas is visually evident in this aerial view. This aerial view, taken on August 29, 2008, depicts the aftermath of flooding in Lake Charles, Florida. Notably, 1 structure is visibly inundated, emphasizing the storm's impact on residential areas. The image provides a clear illustration of the extent of the flooding around the lake. Slide 4 introduces the next subject, commercial structure flooding. We will now turn our attention to the impacts of floodwaters on commercial properties and infrastructure. These investigations will offer insights into vulnerability and resilience in the built environment. This slide identifies 3 commercial properties affected by the flooding. Located in the Orlando area, the highlighted properties are Royal Oak Professional Center, Orange City Medical Office, and Fish Memorial Hospital. These images illustrate the impact of flooding on commercial structures during Tropical Storm Faye. This slide highlights the Fish Memorial Hospital complex in Volusia County. An inset image displays Upper Cape Road flooded, which is adjacent to an industrial park visible in the aerial image. Note the hospital's project location is indicated with a gold arrow, situated on Medical Center Drive. This slide showcases the extent of the flooding at Fish Memorial Hospital following Tropical Storm Faye. The foreground depicts a vast expanse of floodwaters, partially submerging vehicles in the parking lot and encroaching upon the hospital entrance. The severity of the inundation underscores the storm's impact on critical infrastructure. Here we see the location of the Orange City Medical Office, the site of a commercial structure flooding incident. Additional images depict erosion and water damage around the building's foundation and surrounding landscape. These observations underscore the widespread impact of flooding events on commercial infrastructure. This image illustrates the primary point of water entry onto the property of the Orange City Medical Office. Notice the erosional washout observed in the grass where the storm surge first breached the perimeter. Such concentrated entry points contributed to significant flooding and damage within the structure. This slide depicts a site at the Orange City Medical Office. Significant scouring of the landscape is evident in the north car park, revealing exposed pipes and eroded soil. The damage underscores the power of water and its impact on engineered and natural environments. This diagrammatic field note depicts flooding at the Orange City Medical Associates building. Key observations include water flow patterns, marked water levels on the building at an elevation of 47.7 feet, and a wall failure condition on the berm of Pond 1. Survey points and elevations detail various features, including grates, ponds, and the surrounding terrain. This image shows the main entrance to the Orange City Medical Office. Notice the pronounced water stains on the doors and adjacent concrete, approximately 8 inches high. These stains provide visual evidence of the extent of flooding that occurred during Tropical Storm Faye. Here we see the effects of scour along the front landscape area of the Orange City Medical Office. The storm surge created up to 2 feet of erosion, exposing underground pipes and infrastructure. This highlights the vulnerability of structures to flood damage in areas with significant rainfall. Slide 61 illustrates a commercial structure known as the Royal Oaks Professional Center, with an arrow indicating the project location. The surrounding areas show evidence of widespread flooding, including residential areas and roadways, highlighting the severity of the storm's impact on both commercial and residential infrastructure. The photos showcase several areas experiencing inundation, reinforcing the need for improved flood mitigation strategies in the region. This map presents the city limits of Orange City and Debari, the drainage basin for Tremonti Center, and the location of Royal Oaks Professional Park. The image provides a zoomed-in view of the area of interest, highlighting key geographical and jurisdictional boundaries, as well as major roads such as Enterprise Avenue and Saxon Boulevard. A graphic scale is provided to relate map distance to ground distance. Here we see the Royal Oaks Professional Center experiencing extensive flooding. Water has breached the landscape, flowing onto Tremont Drive and surrounding the building. Sandbags have been deployed in an attempt to mitigate the effects of the rising water. Slide 64 depicts the Royal Oaks Professional Center, a commercial structure impacted by floodwaters. The image reveals sandbags stacked against the entrance doors, an attempt to mitigate the ingress of floodwaters into the building. The scene illustrates the severity of the flooding event and the emergency measures undertaken to protect property. This image depicts the pervasive flooding at the Royal Oaks Professional Center. As we can clearly see, the entire car park is submerged underwater, with only the tops of some trees and a lone fire hydrant remaining visible. The scene underscores the severity of the flooding caused by Tropical Storm Faye. Slide 66 illustrates significant flooding at the Royal Oaks Professional Center. The water level appears to be waist-deep in the parking area, with individuals seen wading and even swimming through the inundated landscape. This imagery serves as a powerful visual representation of the widespread impact of Tropical Storm Faye. Slide 5 presents a focus on infrastructure flooding. This portion of the presentation will likely detail specific cases of damage to public works and essential community systems. Understanding these failures is crucial to prevent similar incidents in future extreme weather events. This slide presents an aerial view of infrastructure flooding damage near DeBary, Florida. It highlights the US 17 to 92 corridor at Big Lots Pond and the DeBary Plantation Boulevard, key areas impacted by flooding during Tropical Storm Faye. The image illustrates the widespread impact of the storm on transportation and residential areas. This slide focuses on infrastructure flooding along DeBary Plantation Boulevard. The aerial view highlights extensive inundation near the project location adjacent to Highway 92, with inset images further illustrating the widespread flooding affecting residential areas, golf courses, and roadways throughout the DeBary Plantation community. The severity of the flooding underscores the vulnerability of this region during significant weather events. Here we observe the DeBary Plantation Boulevard neighborhood, post-Tropical Storm Faye. Extensive flooding inundated homes and streets, effectively turning the residential area into a vast network of waterways. This aerial view highlights the widespread infrastructure challenges faced in the aftermath of the storm. This image from DeBary Plantation Boulevard showcases the extent of the flooding following Tropical Storm Faye. Note how the water level has risen to the base of the house, submerging the surrounding landscape and the lower portions of nearby trees. This event exemplifies the infrastructure flooding, which is the focus of this section of the presentation. This aerial view showcases the flooding along DeBary Plantation Boulevard. The image illustrates the extent of the inundation, with roadways and residential areas partially submerged. This widespread flooding resulted in significant infrastructure challenges and property damage, highlighting the storm's impact on the community. This aerial photograph depicts the extent of the flooding along DeBary Plantation Boulevard. Homes are inundated with water, as the image illustrates the devastating impact of the storm on residential areas. The roadway is submerged in certain locations as water levels rise past adjacent trees and shrubs. Here we see the scale of the flooding affecting the DeBary Plantation community. Large areas of the golf course and residential areas are submerged, underscoring the severity of the storm's impact. The floodwaters extend into residential properties, raising concerns about potential structural damage and public health risks. This slide illustrates the project location at US 17 to 92 near Big Lots Pond, utilizing an aerial view for orientation. Visible landmarks include Miller Road to the north and Tremont Drive to the south, with South Volusia Avenue bisecting the area. Inset images highlight infrastructure flooding, underscoring the environmental challenges faced in the region. Here we see US 17 to 92 inundated with floodwaters in the vicinity of Big Lots Pond. The depth of the floodwaters makes the roadway impassable. Such flooding events pose significant risks to transportation infrastructure. This image depicts flooding along US 17 to 92, near Big Lots Pond, highlighting the severe impact of the storm's rainfall. Note the submerged roadway, showcasing the extent of the infrastructure inundation. The photograph serves as documentation of the flooding experienced in the area during Tropical Storm Faye. Slide 6 details the topic of major cover collapse sinkholes, which were a result of Tropical Storm Faye. Cover collapse sinkholes are a common feature of Florida's karst topography, and heavy rains associated with the storm caused ground destabilization across the state. A more in-depth discussion of these sinkholes will follow. This slide presents a map illustrating locations of major cover collapse sinkholes. Highlighted are areas near Deluge Nursery and Fox Lake Drive, as well as Integrated Court and Donald E. Smith Boulevard. These sites experienced significant sinkhole activity, contributing to infrastructure challenges during the storm. This slide documents major cover collapse sinkholes at the Deluge Nursery in Rock Springs. A satellite image of the project location is surrounded by photographs that showcase the sinkhole formations in greater detail. As the slide illustrates, these sinkholes posed significant challenges to the structural integrity of the surrounding area. Here we see significant damage at the Deluge Nursery in Rock Springs. A large sinkhole has formed, collapsing a paved area and exposing the underlying soil layers. This failure highlights the potential for major cover collapse sinkholes in the region. This image, labeled Deluge Nursery, Rock Springs, depicts a major cover collapse sinkhole. The image highlights the unstable geological conditions leading to sinkhole formation, a significant concern following Tropical Storm Faye. This sinkhole is an example of the type of infrastructure failures forensic engineers were tasked with assessing. Here we see a sinkhole that opened up at the Deluge Nursery in Rock Springs, Florida. This major cover collapse sinkhole highlights the effects of the torrential rainfall and flooding associated with Tropical Storm Faye. The eroded hole reveals underlying sandy soil layers, contributing to instability after the storm. This slide displays a major cover collapse sinkhole at Deluge Nursery in Rock Springs. Evidence of the sinkhole's layers can be seen within the exposed earth, providing visual insight into the geological complexities beneath the nursery's landscape. This phenomenon serves as a stark reminder of the unforeseen geotechnical challenges posed by intense weather events. This slide shows a sinkhole location map for the Deluge Nursery in Rock Springs, Florida. The map identifies several sinkholes, labeled SH1 through SH7, with approximate locations marked. Additionally, an area of minor settlement, ranging from 3 to 4 feet in depth, is also indicated. This slide documents a major cover collapse sinkhole at Deluge Nursery in Rock Springs. The image reveals a significant void in the earth, illustrating the instability and hazards associated with sinkhole activity. This documentation is part of an ASCE Geotechnical Group luncheon presentation. This image documents another major cover collapse sinkhole at Deluge Nursery in Rock Springs. The exposed layers of soil and unstable terrain highlight the severity of the sinkhole formation. Further investigation is necessary to determine the underlying causes and potential for future collapses. This slide depicts the project location on Donald E. Smith Boulevard, as indicated on the aerial photograph. The illustration provides context by showing the proximity to the Wedge D subdivision and nearby neighborhoods, with insert photos documenting the major cover collapse sinkholes. In addition, boring logs and transects provide detailed subsurface analysis of the project area. This aerial view of Donald E. Smith Boulevard shows damage caused by a major cover collapse sinkhole. The slide indicates that the sinkhole extends approximately 120 feet from one home and 215 feet from another. Repair equipment sits on the road, likely preparing to address the compromised roadway. Documented here is a catastrophic sinkhole event along Donald E. Smith Boulevard. The subsidence is severe, leaving a large void filled with murky water, indicating extensive subsurface erosion. Caution tape attempts to cordon off the hazardous area, a stark reminder of the instability and danger posed by such geological phenomena. On Donald E. Smith Boulevard, the force of Tropical Storm Faye triggered a major cover collapse sinkhole. The erosion destabilized the pond bank, leading to loss of support for the adjacent roadway. Notice the nearby construction equipment and barriers that indicate a rapid response and remediation efforts to prevent further deterioration and ensure public safety. This aerial view depicts a section of Donald E. Smith Boulevard, where a major cover collapse sinkhole has impacted the roadway. Heavy equipment is on site to address the pavement failure, which has disrupted traffic flow. An adjacent retention pond exhibits signs of algal bloom, perhaps exacerbated by stormwater runoff. This slide illustrates the locations of sinkholes and SPT boring locations in relation to Donald E. Smith Boulevard. Sinkholes are labeled SH1 through SH4, while SPT boring locations are labeled SPT1 through SPT5. Transects 1 and 2 are also indicated, providing a visual representation of the survey lines used in the investigation. This slide shows cross-sections of what appears to be a roadway, Donald E. Smith Boulevard, labeled as Transect 1 and Transect 2. The cross-sections depict elevation and distance, indicating major cover collapse sinkholes. Water level is shown at approximately 55 feet, taken on September 3, 2008. This slide displays soil profiles from SPT borings around the Donald E. Smith Boulevard sinkhole. Data from borings SPT1 and SPT4 are from a residential area. Data from SPT2, SPT3, and SPT5 are from a roadway area. Note the presence of sinkholes at the bottom of SPT2 and SPT4. This slide documents sinkholes along Fox Lake Drive in Rock Springs. Visible are several examples of major cover collapse sinkholes, demonstrating the severity of ground failure in the area. The aerial imagery highlights the project location within a residential neighborhood. This slide depicts sinkholes along Fox Lake Drive in Rock Springs, Florida. Notice the presence of triton barriers, indicating the severity and need for traffic control around these major cover collapse sinkholes. The image is labeled as Photo 1 of 3, suggesting further visual documentation of this incident. This slide illustrates the extensive damage caused by sinkholes during Tropical Storm Faye. Here, we observe a major cover collapse sinkhole on Fox Lake Drive in Rock Springs. Note the presence of accumulated water and debris at the bottom of the sinkhole, suggesting potential subsurface erosion and instability. This image documents sinkhole damage along Fox Lake Drive in Rock Springs. The slide showcases the severe ground collapse resulting from a storm. As indicated, this is Photo 3 of 3 in a series documenting sinkhole damage. Integrated Court in St. Johns County, Florida, was the site of significant sinkhole formation following Tropical Storm Faye. As aerial photography reveals, several major cover collapse sinkholes occurred in close proximity to commercial and residential areas. The location designated on the image is situated near the intersection of Springview Commerce Drive and Robertson Lane. This slide presents an aerial view of the Integrated Court complex. The image reveals a landscape that includes industrial buildings, green spaces, and a storage yard filled with concrete materials. These site features will be discussed in relation to the damages caused by Tropical Storm Faye. This image depicts a major cover collapse sinkhole near Integrated Court. The sinkhole is located adjacent to a parking lot and poses a risk to nearby infrastructure, including power lines. The yellow safety tape highlights the danger and marks the perimeter of the hazardous area. This image depicts a major cover collapse sinkhole at the Integrated Court site. The sinkhole is filled with murky water, and the surrounding landscape shows signs of erosion and instability. A green pipe snakes through the dirt, possibly for remediation purposes. Here we see further evidence of the catastrophic damage caused by Tropical Storm Faye. This sinkhole formed in the Integrated Court area due to the storm's intense rainfall and subsequent flooding. The image captures the sinkhole filled with turbid floodwaters, demonstrating the severity of ground collapse. Here we see a sinkhole that developed in the Integrated Court area. The image shows a large depression filled with water, evidence of significant ground subsidence. Notice the exposed soil layers, indicating the depth of the collapse. Slide 7 introduces a focused examination of pond berm failures resulting from the storm event. These critical infrastructure components played a significant role in water management, and their breaches had profound consequences. The following slides will detail the causes and effects of these failures within the broader context of Tropical Storm Faye's impact. This slide details the pond berm failures investigated during the Tropical Storm Faye damage assessment. Specific sites identified include the Miller Road Pond, Grandayville Apartments, Saxon Trace Apartments, Lowe's Pond, Saxon Woods, and Glen Club Drive. These locations highlight the widespread nature of pond berm vulnerabilities exposed during the storm event. This slide presents an aerial overview of the Miller Road Pond outfall project location. Note the proximity of the pond to Miller Road and its outfall connection to the adjacent wetlands. A detailed photo insert dated August 22, 2008, reveals a pond berm failure, likely caused by the heavy rainfall and subsequent flooding from Tropical Storm Faye. This slide depicts the Miller Road Pond outfall following Tropical Storm Faye. Extensive erosional damage is evident, with significant soil loss and washout around the outfall structure. The photo, dated August 22, 2008, documents the aftermath of the storm's impact on pond berms and drainage systems. This slide highlights the location of the Glen Club Drive pond berm failure, just off State Road 92. The aerial photograph showcases multiple locations where pond berms failed, impacting adjacent properties and infrastructure within the Glen Club Drive community. These localized failures emphasize the vulnerability of engineered systems to extreme weather events. This aerial photograph documents the Glen Club Drive pond berm failure. Visual evidence indicates substantial erosion and washout, likely a direct result of the storm's intense rainfall. Notice the residential homes in close proximity to the pond, potentially increasing the risk of property damage. This aerial view depicts the aftermath of a pond berm failure on Glen Club Drive. The image, labeled Photo 2 of 4, captures the extent of the damage, with significant erosion and water inundation evident in the surrounding area. The berm failure has resulted in a substantial alteration of the landscape, impacting both the pond structure and the adjacent properties. This aerial view depicts the Glen Club Drive pond berm failure, a direct consequence of the torrential rains brought by Tropical Storm Faye. The breached berm has resulted in significant water inundation, as evidenced by the dark, swollen pond waters extending into residential areas. The integrity of the engineered landscape surrounding these homes has been compromised, underscoring the vulnerability of infrastructure to extreme weather events. This slide shows damage to a pond berm along Glen Club Drive. Visible are the erosional washouts caused by water flow. This berm failure highlights a common consequence of intense rainfall events on residential infrastructure. This slide illustrates pond berm failures at the Grandeville Apartments in Orange City, Florida. The aerial imagery highlights several instances of embankment erosion and structural compromise along the pond perimeters. These failures likely contributed to localized flooding and property damage in the vicinity of the apartment complex. Here we see the aftermath of pond berm failures at Grandeville Apartments. The berms have eroded significantly, exposing underlying soils and causing slumping of the adjacent grassy areas. The extent of the damage suggests prolonged exposure to floodwaters. Here we see the erosion and failure of a pond berm at the Grandeville Apartments. The photograph documents significant erosional damage to the berm, resulting in a substantial loss of soil into the pond. This type of failure highlights the vulnerability of earthen structures to prolonged saturation and surface water runoff during extreme weather events. This photograph illustrates the extensive damage to the pond berms at the Grandeville Apartments. Erosion has undermined the grassy areas, creating steep drop-offs into the water. The collapse has also exposed drainage infrastructure, further destabilizing the soil. Slide 119 reveals the extent of pond berm failures at the Grandeville Apartments. Two large drainage pipes are exposed by significant erosional washouts along the pond's edge. The integrity of the berm has been compromised, leading to a critical infrastructure failure. This slide showcases the Lowe's Pond project location, observed here via aerial photography. The surrounding area reveals pond berm failures, visible through associated site photos. These failures, likely triggered by the extreme conditions of Tropical Storm Faye, will be further examined to understand their causes and impacts. This slide illustrates the failures observed at Lowe's Pond following Tropical Storm Faye. Note the breach in the pond's berm, accompanied by significant erosion and washouts. The compromised integrity of the berm structure is evident, requiring a detailed assessment of the contributing factors. Lowe's Pond, a victim of erosion and berm failure. Note the extensive sand deposits encroaching into the surrounding vegetation. This slide is Photo 2 of 3, documenting progressive failures within the pond structural system. Here we observe a pond berm failure at Lowe's Pond. Note the displaced concrete slabs and the collapsed section of chain link fencing along the water's edge. The area is overgrown with vegetation, indicating a potential lack of maintenance contributing to the failure. Here we observe the Saxon Trace Apartments, the focal point of our investigation. This slide illustrates various pond berm failures within the Saxon Trace area, highlighting the localized impact of the storm's intense rainfall. The yellow indicator pinpoints the project's location amidst the surrounding street grid. This image, labeled Photo 1 of 6, shows the Saxon Trace Apartments. A roadside drainage ditch overflowed, as seen by the standing water alongside the adjacent roadway. This presentation is being given to the ASCE Geotechnical Group Luncheon. The Saxon Trace Apartments experienced significant pond berm failures, as evidenced in this image. Here, we see a compromised berm with displaced soil and pooling water, indicating a breach in the pond's containment. This failure likely contributed to flooding and erosion in the surrounding area. The Saxon Trace apartments experienced flooding after the storm, resulting in pond berm failures. Note the pond banks are compromised, with portions of the ground eroded into the water. Also, a concrete structure is partially submerged in the foreground. This slide presents a visual record of pond berm failures at the Saxon Trace apartments. The photograph captures significant erosion and undercutting along the pond's edge, demonstrating the impact of intense rainfall. Such failures can compromise the structural integrity of surrounding areas, leading to further property damage. At Saxon Trace apartments, significant erosion has occurred adjacent to a retaining wall and roadway. This failure resulted in a substantial sinkhole formation. Mitigation will require extensive earthwork and stabilization to prevent further damage to the adjacent infrastructure. Saxon Trace apartments suffered failures of the pond berm system. This photograph shows the destruction of the berm, as the structural blocks have crumbled and collapsed. The underlying soil has also been eroded, further compromising the berm's integrity. This slide focuses on pond berm failures in the Saxon Woods community. As the aerial imagery indicates, the project location is near State Road 92 and N. Charles Richard Beall Boulevard. Multiple ponds are visible in the overview map, with inset images highlighting specific failure points. Saxon Woods, pictured here, experienced pond berm failures as a result of Tropical Storm Faye. The photograph shows the ponds and berms surrounded by residential and commercial developments. The proximity of these structures to the water bodies highlights the potential for significant damage when berms fail. Here we see the Saxon Woods site, post-storm. A bulldozer is on scene performing remediation on the pond's berm. Extensive erosion into the pond can be observed along the disturbed shoreline. This image documents the situation at Saxon Woods following Tropical Storm Faye. We observe significant ponding throughout the residential area and overflowing into the adjacent property. The extent of the flooding is clearly visible in the saturated ground and overflowing ponds, indicating a failure in the site's water management system. Slide 8 presents a discussion on erosional washouts. This section likely covers the causes, mechanisms, and extent of soil erosion observed in Florida following Tropical Storm Faye. Further slides will likely highlight specific case studies or examples of erosional damage. This slide depicts erosional washouts, likely a result of the heavy rainfall associated with Tropical Storm Faye. Evident in the satellite imagery is the project location in a residential community, with supporting photographs indicating severe land erosion and potential infrastructure damage. Such washouts pose a significant threat to structural integrity and require immediate engineering intervention. Here we see the effects of erosion along Donald E. Smith Boulevard. The loss of soil integrity has led to a dramatic washout beneath the surface vegetation and fencing. The exposed earth reveals a composition of sand and other unconsolidated materials susceptible to further erosion. This slide depicts erosional washouts on Donald E. Smith Boulevard. Observe the significant soil loss and the formation of a deep gully, indicative of substantial water runoff and erosion. This type of damage can undermine infrastructure and pose safety risks. Moving on to erosional washouts, we see a significant gully formed along Donald E. Smith Boulevard. This erosion occurred after prolonged rainfall weakened the soil structure. The resulting washout undermined the surrounding landscape. This image captures the erosional washouts along Donald E. Smith Boulevard, another area impacted by Tropical Storm Faye. Extensive erosion is visible along the banks of the waterway, undermining the structural integrity of the surrounding landscape. This washout demonstrates the powerful erosive forces unleashed by the storm's torrential rainfall. Slide 9 introduces the discussion of infrastructure failures experienced as a result of Tropical Storm Faye. We will be examining failures in conveyance systems, responsible for the transport of water and wastewater, as well as related issues. These systems are particularly vulnerable during extreme weather events. Here we observe a project location within the Debari Villas community, impacted by failures of conveyance systems. The image reveals damage to roads and infrastructure, with visible flooding and erosion affecting multiple residential areas. The proximity to roadways like Highway 17 and 92 indicates widespread effects on the surrounding transportation network. This aerial view of Debari Villas reveals significant erosion and structural damage following Tropical Storm Faye. Note the extensive sinkhole formation near the parking area and the compromised pond bank, underscoring the storm's devastating impact on infrastructure. The combination of heavy rainfall and compromised conveyance systems led to widespread damage in this community. Here we see the devastating effects of erosion at Debari Villas. The road has been completely washed out, leaving behind debris and exposed infrastructure. This scene highlights the power of floodwaters and the vulnerability of civil infrastructure in the face of extreme weather events. Here we see Debari Villas and more effects of flooding. Notice the complete erosion of the road and supporting structures, and the standing water in the neighborhood, all the result of conveyance system failure. As shown, these failures resulted in significant structural damage and accessibility issues. Here we see catastrophic erosion of a road embankment at Debari Villas. Significant rainfall eroded the embankment and undermined the asphalt roadway. A failed stormwater conveyance system is also visible. Here we see the devastating impact of the storm surge on infrastructure at Debari Villas. The road has been completely undermined, with large sections of pavement collapsed and washed away. Exposed water pipes further illustrate the extent of the damage and potential disruption to essential services. Slide 10 highlights the pivotal lessons learned from the Tropical Storm Faye disaster, which inform our understanding of infrastructure resilience. These insights guide future directions in engineering practices, infrastructure design, and emergency preparedness to mitigate the impact of similar extreme weather events. They will also help the engineers to build better in the future. This slide provides a technical summary of the findings. Stormwater pond berm failures were similar across all instances, and pond slope failures were attributed to overtopping rather than conventional slope instability. Sinkhole collapses were typical and correlated with rising superficial aquifer levels, internal erosion, and buried karstic cavities, commonly observed in thinly mantled karst regions. Additionally, a dam breach analysis is sometimes necessary to assess the downstream impacts on conveyance systems. The technical summary continues with key regulatory concerns for landlocked ponds. Properties at the bottom of landlocked basins suffer the most long-term impact, requiring shared responsibility in mitigating damages. Finally, urbanized areas with numerous landlocked basins are particularly susceptible to damage, necessitating regional pumping systems or revisiting drainage wells. This schematic represents the City of Debari West Side Emergency Flood Management System project. Several phases of stormwater management infrastructure are highlighted, including force mains and regional storage facilities. A network of lakes and ponds are interconnected with existing and planned underground systems. This map of Debari, Florida, marks locations affected by the Stormwater CIP program. Highlighted in red are a series of stormwater-related projects numbered from 1 to 25 and 10B, 15A, and 15B. These projects are associated with drainage improvements, roadway repairs, or construction intended to mitigate future storm damage.